Hello students, welcome back to RD Chemistry. In this module, I'll explain aldol condensation from aldehyde ketones and carboxylic acid chapter. What is aldol condensation? Aldehydes are ketones which contain at least one alpha hydrogen atom in the presence of dilute bases like either sodium hydroxide, potassium hydroxide, or barium hydroxide. The bases from group number 1 and group number 2 of S block elements. They form beta hydroxyaldehyde ketone, which is known as the aldol product. And this is the addition product here. On heating strongly, this loses a molecule of water finally to form alpha beta unsaturated aldehyde or ketone. Okay, let us see the example now. Consider acetaldehyde CH3C double bond OH. This is a functional group. With respect to the functional group, next carbon is alpha carbon and the hydrogen is called as the alpha hydrogen. So this molecule is alpha hydrogen. So what I'll do now, I'll be writing two molecules of acetaldehyde. First molecule like this. Second molecule CH3, I'll split as the CH2 one hydrogen separately, then C double bond OH. Okay, this is the acidic hydrogen. This is the acidic hydrogen. Alpha hydrogens are the acidic hydrogen because it is next to the electron withdrawing CO group. Okay, so during the reaction, hydrogen goes to the oxygen, carbon-carbon new bond is formed. Therefore, we are going to get CH3, C, OH, hydrogen is attached, then CH2 is there, I'll again split it, CH and CH, then CHO. This is the aldol product we have. So there is the aldehyde and alcohol group, OH group. So it's called the aldol, aldehyde plus alcohol. This on strong heating loses a molecule of water to give finally CH3CH double bond CH single bond CHO. Okay, so with respect to the function group, alpha carbon, beta carbon, multiple bonds are there, so unsaturated aldehyde. This is the beta hydroxy here. With respect to the function group, alpha carbon, beta carbon. So it is the this is the beta hydroxy compound. This is the beta hydroxy aldehyde compound, which is known as the aldol product here. Fine. Let us see the example of acetone. Acetone is the CH3C double bond CH3. Okay. With respect to the functional group, next carbon is alpha. Here there are two alpha carbons, so we can call it as the alpha and alpha dash. So we have got CH3C double bond CH3, first acetone. Second acetone, I'll take it as the CH2 one hydrogen separately. It is the alpha carbon atom, alpha hydrogen, then remaining C double bond CH3. Fine. Hydrogen to the oxygen, carbon carbon new bond is formed. Therefore we get CH3 C single bond OH attached to the CH3. Then we have got CH2 C double bond CH3. Okay, so with respect to the function group, alpha carbon, beta carbon, correct? So this is a beta hydroxy ketone. Therefore this can also be called as the ketol, but the reaction is generally called as the aldol, so it can be ketol also. Okay, now I'll split this again alpha hydrogen into CH and NH separately. On heating strongly, loses a molecule of water to give CH3C H3 here, double bond CH, single bond C, double bond CH3. With respect to the function group, alpha carbon and beta carbon, alpha beta unsaturated ketone it is. Is that fine? Clear? Whatever aldol condensation spoke about is also known as the self condensation, self aldol condensation, because two molecules involved of the same type. Okay. Second one is called the cross aldol condensation. Cross aldol condensation. Here we will take two different aldehydes or two different ketones or one aldehyde or one ketone, and at least one of them should contain the alpha hydrogen. So I'll go for cross aldol. So I'll take one molecule of acetyl benzaldehyde. So this is the benzaldehyde. Second molecule I'll take it as the acetaldehyde. You know that acetaldehyde contains acetaldehyde contains alpha hydrogen atom. It contains alpha hydrogen atom. There is no alpha hydrogen on the benzaldehyde. Okay. So in the presence of dilute sodium hydroxide, hydrogen goes to the oxygen, carbon new bond is formed. Okay. So we get a benzene ring attached to the C, OH, single bond H, single bond C, H and H are split now, then CHO together, right? On hitting strongly, you lose a molecule of water to give finally benzene ring attached to the CH, double bond CH, single bond CHO. Okay. This compound commonly called as the cinnamaldehyde. Cinnamaldehyde. This is the cinnamaldehyde. Okay, fine. Again, I'll take the example of benzaldehyde and acetophenone. Okay, benzaldehyde C double bond OH, and acetophenone. Acetophenone is a CH3. I'll split that as the CH and CH2. C double bond O, acetophenone benzene ring. This is alpha carbon. Hydrogen goes to the oxygen. Carbon new bond is formed. Therefore, we'll get now addition product benzene C. I'll write OH up and hydrogen down. Then C H2 I'll split here. Then C double bond O attached to the benzene. On strongly heating, loses a molecule of water. So finally to give this molecule CH double bond CH single bond C double bond O attached to the benzene. And this compound is also called as the, this is from benzaldehyde and acetophenone. Benzaldehyde and acetophenone. Acetophenone. Therefore, this compound is called the benzal acetophenone. Benzal acetophenone. Benzal acetophenone. Is that fine? Clear? Let me take example of cyclohexanone. These are cyclohexanone. So we'll be writing now the aldol for cyclohexanone. This is the first molecule. Second cyclohexanone molecule I'll write like this. Okay. And with this CO group, this is alpha carbon atom. There are two alpha hydrogens are there, correct? So hydrogen goes to oxygen and carbon new bond is formed. Okay. So in the presence of dilute sodium hydroxide. So this will be now, it forms the OH. I'll rotate the structure. So it forms the OH. New bond is there, correct? Then it is attached like this and double bond here, correct? One more hydrogen is there, correct? Which I shown there, alpha hydrogen. On strong heating, it loses a molecule of water to give finally structure like this. Okay, structure like this. Fine. Hope this is clear to you. Condition is that there must be alpha hydrogen atom on the aldehyde or ketone. In the presence of dilute sodium hydroxide forms aldol addition product, loses a molecule of water to give alpha beta unsaturated aldehyde ketone. Okay, fine. If you like this video, please do like, share and subscribe and support me. Thank you for watching. Have a nice day.